Hi everybody, my name is Oleg and we are talking about the welding. I'm often asked the same question, how to choose the right current for welding? Experienced welders, by the way, from the first seconds of welding process can tell is it okay with the current or no. Furthermore, after the cleaning, the welds is necessary to examine, so you need to answer the question about the uniform of the welding seam. Is it good or no, to conclude the correct or incorrect current selection. I'm not going to discuss about this complex subject. I decided to show how this can be done practically. This technique used by almost all welders. What can we do? The first, find a piece of metal of the same thickness as the welded parts. The second, make a few welds on a plate of metal with different currents. The third, choose the best. Let's choose the electrodes for welding. The first type of electrodes, rutile coated electrodes thin coats. Look at the box of the electrodes. The diameter is 2.5 mm. Preferable welding current alternating. If welding is carried out with a direct current, connect the electrode negative. The welding positions all except vertical down. The range of recommended welding currents from 65 to 90 amperes. The next type of electrodes, base coated special. The diameter is the same, 2.5 mm. Note that here we use the direct current, electrode positive. Welding positions all except vertical down. Welding currents from 50 to 95 amperes. Usually rutile coated electrodes need a little more current than the same base coated electrodes. So the first weld, rutile electrode, negative, welding current 65 amperes. It can be clearly seen that the paddle is quite cold. Metal spreads poorly on the details. The welding process is too slow. The arc burns dimly. It is unstable, i.e. it walks from side to side, so it affects the seam. Let's clean the weld and look at that. The form of the seam is incorrect. It is too narrow and high. On the border between the weld and the base metal are clearly visible dark spots, the small holes. That means that poor fusion between the weld and the base metal. In cross-section, acute weld is visible. Let's do the next weld. Rutile coated electrode negative, the current is 78 amperes. Please note that the liquid metal better spreads on details. Welding is faster. The arc is more stable, more penetration. It is necessary to clean off the slag and to inspect the weld. The weld has a flat top, wider than in the first case. Poor fusion is not visible. In principle, the current appropriate, but I would add 5-7 amperes. And finally the third weld, rutile coated electrode negative, current is 95 amperes. Look at the fact that the paddle is very fluid. It's difficult to manage. Metal excessively spreads over the surface. Quite a lot of large and small sputters are produced around the weld. Welding by this current is very fast. The arc is very bright. Clean off the slag and inspect of the weld. The width of weld is more than necessary. Excessively flat top. We see a large amount of sputters, which is not typical for rutile electrodes. We turn to the welding with the basic coated electrode special. The first weld, electrode positive, current is 50 amperes. Please note, the burning of the arc is not very bright. Metal spreads poor. Weld has a rather narrow and high shape. Note that even the appearance of slag differs from the slag with the rutile electrodes. This slag has more density and more fragile and cleaned much more difficult. This requires much more time to clean up the weld. Here the slag is visible on the edge of the weld. As you can see, the shape of weld in this case is similar to seam welded by rutile electrodes. It is too narrow and high. Current is clearly not enough. The next seam, basic electrode positive, current is 73. In this case I would say that this is the optimum welding current. The metal paddle is well managed, welding is relatively fast, low sputters. The liquid metal spreads well on the plate. Let's operate the electrode that the slag is not much running ahead, not behind the arc, and cover the whole welded seam. Thus we protect the welded metal from the influence of the air. Pay attention to the final piece of the weld, the place where we finished welding. Here, as well as at the beginning of the weld, the defects occur more often. Let's clean off the slag and look at weld. The seam has a regular geometric shape with a flat top and a smooth transition to base metal. This form of weld is obtained by properly combination: the welding current, the welding speed, the electrode slope, and the length of arc. The last weld, electrode positive, welding current is 90 amperes. The puddle is practically difficult to control. The liquid metal is instantly spreads in all directions. Because of this, electrode manipulation is complicated. It is difficult to get the identical width and height over the entire length of the weld. Look at the slag covering. It has gaps and discontinuities. All this leads to defects. Let's see the weld carefully. Because of the high current value, the electrode have to move more quickly. It is affected the weld uniformity, narrow sections alternating with broader. The first figure, welds of insufficiently currents. On the left, base-coated, on the right, rutile-coated electrode. The next figure, these seams are welded at average currents, 72 amperes on the left and 78 amperes on the right. Welding currents are close to optimal. The last figure, these seams are welded of maximum allowable current for the electrodes. Definitely currents is too large. Lastly, at the request of the commentators, fillet weld vertical up basic coated electrode. The analysis of weld will be in the next video. Thank you for your attention.